Here, an AP Math student is tackling some more technical integration questions that involve trig. So she was looking at this particular question and she said, to integrate by parts, I know we make the algebra the function and the trig the derivative. That's in the formula where one of the function acts as an actual function and the other one acts as a derivative in the formula. But for the more complicated examples, I'm so confused as to where the derivative came from. So she worked through this example, which I worked through in one of my videos. So she had a look at that and didn't know where that derivative function came from. So what I'm going to do is I'm actually going to tackle this question in a slightly different way than I did in the video. So you can always go back to the video on integration by parts and have a look how I did it there. But I'm going to tackle it in a slightly different way, which maybe will make more sense. So I've just popped my integration by parts formula that comes straight off the AP Maths formula sheet. Just pop that over there. Now let's tackle this question. Okay, so I've got the integral. Oh, let's go back to the other color here. Alright, so I've got the integral of x times by sine squared x with respect to x. Now I try inspection, but the problem is I can't do inspection because here's my composite function and I don't see the derivative of my inner function, which is cos x. I have an algebraic function. So when you have the product of an algebraic and a trig function and they're seemingly unrelated, you use integration by parts. Now what we do with integration by parts is we immediately write down what our function and what our derivative is. Now the key is always choose the algebra function as the function and choose the trig function as the derivative. So I'm going to choose sine squared x. And this is not quite what I did in the video, but you'll see if you work through this question now how it links to the way I did it in the video, but this could make more sense. That's because we've got f of x and we've got the derivative. Now we need to differentiate that. So I've got the derivative of f, which is 1, and now I actually need to find the original function. So I need to say, okay, well, what is this original function? Now remember, to get from a derivative to an original, you do the opposite of differentiating. In other words, you integrate. Let me just plug in my computer here so that it doesn't die partway through. Okay, so what we're going to do is we're going to integrate this function, and you can just go do that on the side. So let's go and integrate this function. And then I'm going to pop that back in that position. So bear in mind, I haven't gone to the formula yet. All I'm doing is integrating my sine squared x with respect to x so that I know what to put in place of that question mark. Now, if you integrate this, you immediately try inspection, and you see that that's your composite function with sine x being your inner function. The problem is you don't have the derivative of that inner function, which is cos x. You can't see it. So what we can do is we use one of our identities. You can look at one of our videos where I explain the identities, but I can replace sine squared x with a half minus a half cos 2x with respect to x, and then I split it. So I've got the integral of a half with respect to x minus, and I'm going to take that half out, the half integral of cos 2x, or the integral of half cos 2x with respect to x. Actually, I just want to create a little bit of space here. You'll see just now. Oh, never mind. Let me just rub this out to create a little bit more space. Okay, so of cos 2x, yeah, with respect to x. Okay, so what I'm going to do is the integral of a half is a half x. Then I've got minus. Now, I want to, there's that half that's just sitting there. I want to integrate cos 2x, or as this particular students will say, cos junk, because we don't really care about what that is. So I've got cos junk. I want to integrate that. Now, according to my table, let's pop my table over here, according to my table, the integral of cos of something, cos junk, is sine junk. But however, in order to use inspection, I need to see the derivative of the inner function. So that's why at this point I put the derivative of my inner function, which is 2x, the derivative, I put a 2 there. And then I times by half to compensate for that 2, so that I can use inspection. So there's my half. Let me just take this out here. Take that, don't need that yet. Okay, so here I've got a half times a half, which is a quarter. And the integral of 2 cos 2x, well, the integral of cos junk is sine junk. So I've got sine 2x, and then I would add my constant of integration. But I don't have to here, because actually what I was looking for is what goes in that question mark. So let's take that question mark out and put this whole story in there. A half x minus a quarter sine 2x. That's my function g of x, because it's the integral of sine squared x. If you had to go backwards, you would get all the way back to that expression, which can be replaced with sine squared x. Now I can take all of that. Let's get rid of this table for the moment. Now I can take all of that and put it back into my function, because I've got all of this stuff that goes in here. So let's do that. I'm actually going to take us on to the next page. Okay. Alright, so I've got my functions that can go into my formula. Now remember, integration by parts, you've got to take your f and you times it by your g. That's the first thing. So I've got x times by a half x minus a quarter sine 2x. And then you subtract the integral, and we'll have a look back at the formula. You subtract the integral of g times the derivative of f. So the integral of g, which is sine squared x. Oh, sorry. Let's just have a look here. Sorry, you times by the integral of g, yeah, so it's that whole story. I've got a half x minus a quarter sine 2x multiplied by the derivative of f, which is 1. So you multiply by 1, and I'm integrating with respect to x. This I can just times out, so I've got a half x squared minus a quarter x sine 2x. Then here I'm going to split, so I've got minus a half the integral of x with respect to x. Minus and a minus is a plus, a quarter integral of sine 2x with respect to x. Okay, so these guys just sit there. Half x squared minus a quarter x sine 2x. Then I've got the integral of x is x squared, and then remember I times by half, so I've got that half that's already sitting there, and then I've got a half x squared for the integral of x. Now, if you have a look at, I want to get the integral of sine 2x, sine junk, but I need to see the derivative of my inner function, so I need to see a 2 there. Okay, just actually move it over a little bit. I need to see a 2, so I compensate by timesing by a half. Now if you look at your table, oopsie, let's just, if you go back and look at your table, because I don't have it now, if you go back and look at your table, you will see in the derivative column that you need a negative sine junk, because you can only integrate that. So you introduce the negative, provided you introduce a negative in front, so that positive becomes a negative. So here I'm going to have negative, and then a quarter times a half is an eighth, and the integral of this here of negative sine junk is cos junk, so cos 2x. And now I've integrated everything, so I add my constant of integration, and then I'm going to simplify. So I've got a half x squared minus, and that's actually a quarter x squared, which gives me a quarter x squared. Then I've got minus a quarter x sine 2x minus an eighth cos 2x plus my constant of integration. So I hope that sheds a bit more light on how we got this function. So I did it a little bit more differently. I did than I did in my videos. I did this whole story, and I think maybe it's easier to pick that as my derivative function, go onto the side, use a pencil or another color so that it stands out for you, actually integrate in order to get that function, take that function and put it into your formula. So I hope that sheds light. If there are any further questions from the student who posted this or from anyone else, just let me know.